In this video, we are going to be determining the number of subsets for a real-world situation. Okay, so we've got a little help here. If a set has n elements, then the set has 2 to the n distinct subsets. Okay, so that's 2 to the power of n. So in other words, for example, if the set has 3 elements in it, and you're asked, how many distinct subsets do you have? Well, we know that the n is 3 because I said there was 3 elements in it. So you would just do 2 to the power of 3. Okay, and if there were 5 elements, then you do 2 to the power of 5 and so on. Okay, now we have some special cases. If they say, well, only some or none is possible. Okay, you can't choose all, in other words, all is not possible. Then there are 2 to the n minus 1 possible choices. Okay, so if it says only some or none are possible, then what you're going to do is still do 2 to the n, but you will subtract 1. Likewise, if it says if only some or all are possible, so the empty set, none is not possible, you do the same thing. 2 to the n, and then subtract 1 from that. Okay, so let's look at the first one, see if we can do it. Dak is going on a trip. He can take some, none, or all of the 8 novels from the list below with him. Ascent, Beloved, Emma, Dune, Glory, Lost, Frankenstein, 1984. In how many different ways can Dak choose the novels to take with him? The order doesn't matter. Okay, so all we have to say, we have to look at what it says closely. It says he can take some, none, or all. Okay, so is that these two cases? This says some or none are possible, but all is not possible. No, this says all is possible. This says only some or all are possible, but none is not possible. But this says none is possible. So this has no restrictions. So this is going to be the first one. If a set has n elements, then there are 2 to the n distinct subsets. There's no restrictions. You can take some of them, all of them, none of them. Okay, so all we have to do is count up the elements 1, 2, 3, 4, 5, 6, 7, 8. And we do 2 to the power, well, we say n is equal to 8. So the subsets is 2 to the power of 8. And if you put that in a calculator or you multiply it out, it's going to give you 256. That is 2 times 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 2. 8 times. I think I said that right. Okay. Number 2. By the way, this is the answer. This is the number of subsets you can have. Okay, Jasmine, a college freshman, is deciding on classes for her first semester. She can choose to take some or none of the 6 classes below. She cannot take all of them. Okay, so let's, before we try to figure out this problem, which case is this? Some or none are possible, but cannot take all. That's the second case. So this is going to be one where we do 2 to the power of n, and then we subtract 1 from that answer. Okay, so we've got 1, 2, 3, 4, 5, 6. So n is equal to 6. That's how many elements are in the set. So we're going to do 2 to the 6 minus 1. We can do that in the calculator real quick. 2 to the 6. That's 2 times 2 times 2 times 2 times 2 times 2. Okay, that's 64. And then we subtract 1, and of course that will give us 63. So there were 63 possible subsets. How many different ways can Jasmine choose to take classes? 63 different ways. Okay. Last one. There are 9 members of the jazz club who are listed below. A concert director can choose some of them to be a part of the show. The director cannot choose all members, okay, but they have to choose at least one. So that means all is not possible, but some are none. So that is case number 2. Okay. It says that we can do cannot choose all. So that's this one. All is not possible. So this is again 2 to the n minus 1. Okay, so we just need to count. Angel, Micah, Victoria, Wendy, Fatima, Aiden, Anthony, Jacqueline, Eric. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 elements. Okay, so n is equal to 9. That's how many elements we have. And how many subsets can we have given these restrictions? It's going to be 2 to the 9 and minus 1 because we can't choose them all. Okay, so let's go to our calculator again. 2 to the 9, 512. Then we subtract 1 and we get 511. So our answer is 511 different ways of setting up the jazz club.